Section 1B, multiplying and dividing radicals. We're going to start with number 17. We have two different radicals being multiplied. The rules basically state that we're going to take the outside pieces times each other and the inside pieces times each other. Outside being outside the root, which gives us -4. Inside meaning inside the root, which gives us a root of 6k, and we're multiplying now, so powers are added to the fifth power then. And then we look for, again, pairs. So 6 is 3 and 2, so there's no pairs there, but we do have k, 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 k. There's 5 of them, so we can take out a pair and another pair. So we're left with a -4, a k, and another k. On the inside, we're left with still the 6, because 3 times 2, and then we have a k. So our final answer would be -4 k squared root 6x. Or excuse me, 6k. There we go. Now that's multiplication of radicals. Division of radicals, we'll look at number 21 for this. The root, or the fraction with two different roots is the same as the root of a fraction. So I can write this as one big root and write it as 3a squared over 15a to the 4th. Now that's the same as 3aa over 15aa. Again, that's one big root. And I do this because it's a fraction, so I can simplify like I normally would. I can take a pair of a's out. I can simplify the 3 to a 1 and the 15 to a 5. And that gives us 1 on top and 5a squared on the bottom. Now that is underneath one big root. And now I can put them back into their own separate roots, top and bottom. And we have one thing to worry about here, and that's a root in the denominator. We can't have that, so let's see what happens. First of all, the nice thing is root 1 is 1. If we look for prime factors, here we have a pair of a's, which means that can come out, and that would give us an a root 5. Now since that is simplified as far as it can go with respect to the roots, we have to fix the fact that we have a root in the denominator, and that is not acceptable. The way we fix that is to do what we call rationalizing. And we take the problem, which is root 5, and we multiply by root 5. The fraction has to be proportional, so we multiply top and bottom by the same thing. And the top is 1 times root 5, which is root 5. On the bottom, you get a root, and that becomes 25. 5 times 5. And the reason that's nice is because root 25 is 5, and we still have our a. And this is considered rationalized and simplified. So it's okay to have a root in the numerator, but it is not acceptable to have a root in the denominator. And again, notice I multiplied top and bottom by root 5, not times a root 5, because a is okay.